Okay, so last class, like 2 weeks ago, we talked about radians, right? Who can remind me what a radian is? Good job, guys. Who remembers the last time we were in class? It's that long ago, right? All right, so a radian is a unit of measure, just like degrees, okay? Radians describe the measure of an angle. So instead of saying it in degrees, we are going to be using radians because we're talking about trig now, right? So just like we could use feet or meters, we can use degrees or radians, okay? So we talked about radians, their conversion between radians and degrees. We're going to talk a lot more about that today. So now a couple that I told you had to memorize. We said that 2 pi was equal to how many degrees? 360 degrees. Good. So 2 pi was equal to 360 degrees. So what was pi equal to? Very good. How about pi over 2? 90. It's half a pi, right? And the hard one that you guys couldn't get, 3 pi over 2, which is? 30. 3 pi over 2 is 1.5 pi. Yes, we definitely did. Huh? 270 degrees. Yes, we definitely did. Yes, we did. Yes, we did. Oh, you guys make me want to rip out all of my hair sometimes. Okay, so let's backtrack because, whoops, we're going to pretend that we didn't do this. All right, so we're going back. Theta, that's a theta. Okay. We're all the way back on 1.8. That's not even humanly possible. We did reference angles because you had a quiz on reference angles. Okay, so I guess we're just going to start talking about radians then. How about that? Oh my good. Okay. All right, so radians are a unit of measure, just like degrees, except we're going to be using radians. It's a different way to describe it, okay? Just like meters and feet. So we just talked about some very important stuff. You guys were quick. This is good. Okay, so in your notebook, are you ready? We're going to start talking about rotations, all right? Now, normally we say that this is 0 degrees, right? It's also 0 radians. This was how many degrees? 90. This is 270. Okay, so we said that one full rotation is 2 pi radians. One full rotation is how many degrees? 360. So we're going to say that this is 2 pi radians. Where we would usually put the 360, we're going to put 2 pi radians. Okay? So now let's use some common sense. If one whole rotation is 2 pi, what's half a rotation? Pi. That's your 180, right? So 2 pi is 360. Pi is 180. So let's get a little bit further. A quarter of a rotation is going to be half a pi. Pi over 2, right? If this is one whole pi, this is a half a pi. Are we okay with that? All right, so if this is a half a pi, this is a whole pi, this has to be a pi and a half. How do I write a pi and a half? Beautiful, 3 pi over 2. And how many degrees is 3 pi over 2? 270, good. Okay, so those ones you have to have memorized. You just have to know them off the top of your head. You have to know 2 pi is 360, pi is 180, pi over 2 is 90, 3 pi over 2 is 270. Just have to know them, okay? We are going to learn a whole bunch more in between. You're going to be learning what 45 degrees is, what 30 is, and what 60 is. And then from there, we'll be able to find what every single other angle is by just finding a pattern, okay? So really, if you think about this, this is a pattern as well. This is 0 pi over 2, 1 pi over 2, 2 pi over 2. Why 2 pi over 2? Yeah, right? 3 pi over 2, and then 4 pi over 2. So do you see the pattern? So when we start breaking it up even further, we're able to find more of a pattern. So let's think about 45. Okay? Think about 45 degrees. I want to know what that is in radians in terms of pi. So if it's halfway between a half a pi and 0, what's halfway between a half and 0? A quarter. So how do I write 1/4 as fraction? 1/4. So this is going to be pi over 4. Make sense? A half of a half is a quarter. So if I think about breaking all of these in half, let's think about my pattern. This was 0 pi over 4, 1 pi over 4. What would this be? 2 pi over 4. 2 pi over 4 reduces to a half. This is going to be 3 pi over 4, 3/4 of a pi, right? This is 4 pi over 4. This is 5 pi over 4. This is. So if you can figure out the pattern, how you're breaking it down, this becomes really simple. Okay, and we're going to do a lot of this tomorrow. All right? Okay, so 0 pi over 2 pi, 3 pi over 2, 2 pi. Real quick around that unit circle. Okay? All right. Radians can also be written as a decimal. You don't always have to see the pi in there. A lot of times what we'll do is we'll just plug that pi in and get a decimal approximation for it. So you're going to see it written both ways. So you have to make sure that you're clear with that. I can have 2 radians, or I can have 2 pi radians. Those are 2 completely different things. You notice that little r? That's just notation for radians. Okay? So these are 2 very different angle measures. One's written with the pi, and one is written as a decimal. Okay? All right. So let's go a little bit further. Why do we use this? Well, radians actually get used for a lot of things. One thing that we're going to be using it for is to find something called an arc length. You guys remember arc lengths from geometry? What was an arc length? Yes, it was last year. What's an arc length? Where do we see arcs? Circles. Oh, yes, thank you. Okay, so we see arcs and circles, right? So if I were to take and make a circle, right? And let's say I put an angle in there, looks like this, and I wanted to find this. This right here is my what? My arc length, right? So we're going to learn how to find these arc lengths, but in order to find them, we have to use radians. So this is one of the reasons we learn how to find radians instead of degrees. Okay? We wind up with this really important formula that you have to have memorized. It's not given to you. And that formula is S equals R theta, R times theta. And there's a bunch of different variations that you can change this formula around so that it's theta equals S divided by R. It doesn't really matter which way you choose to do it. I always use S equals R theta because it's easier for me to remember. Okay? So kind of important, you need to know what the S, the R, and the theta stand for, right? It is arc length formula. Yeah, this is how we're going to find arc length, or radius, or theta, depending on what we're looking for. Okay? So what do you think the S is? Yeah, good. So S is arc length. All right. What do you think the R is? It's radius, yeah. Okay, so this right here would be your radius, where the arc meets the segment, okay? Ray, I guess. And theta? What's theta? What do we use theta for? What do theta generally represent? the angle. Okay, so this is the angle of rotation. Now the key is, it has to be in radians. And if it's not, you can't do it. You can, you just have to convert it to radians. Okay, so that's this piece here. Theta is your angle of rotation, your radius, and your arc length. All right, S equals r theta. Arc length equals the radius times the angle of rotation. Okay, so let's learn how to use it. All right, so that's just a picture of what you already know. We have some keywords that are going to go along with these types of problems. They are almost always word problems, almost always, okay? So again, your formula, S equals r theta. So the types of problems you might see: pendulum, clocks, Ferris wheels. So these are all word problems. These are kind of key things that pop up. Dog on a chain. Like if you chain a dog up to a pole, it can run around it and it creates an arc, right? So those are all things that come up. So anytime you see that or arc length, you're automatically going to use this formula. Okay? For us, that's the only time we see something with arc length. Got it? Okay. All right, so first problem, determine the number of radians that the minute hand of a clock passes through if it has a length of 5 inches and its tip travels a total distance of 13 inches. It is imperative that you guys draw pictures for these. Okay, you have to get used to drawing pictures. All right, so let's think about a clock. What shape is the clock? Circle. Okay. Circle. How do minute hands move? Yeah. Okay. So let's say here's the center of my clock, and I've got my hands moving. Let's say it looks like this. Okay. They've moved. This is a terrible picture. All right. So to blow this up, let's say it looks like this. You guys okay with that? So it's a piece of my clock, a portion that it's been, my minute hand has moved. All right, so determine the radians in the minute hand of a clock that passes through if it has a length of 5 inches and its tip travels a total distance of 13 inches. So S equals r theta. I'm dealing with a clock problem. So I need to know what I'm looking for. What's my missing piece here? What am I looking for? I'm looking for theta. Why? Yeah, I want to determine the number of radians. Radians means I'm looking for the angle. I'm looking for theta. So that means I have to know my radius and my arc length. So which one of these is my radius? 5 is my radius. Good. That's the length of the piece. And 13 is going to be my arc length, the distance that it has traveled. And then I'm going to be looking for theta. Okay, so you have to be able to draw the picture. So I've got 13 equals 5 times theta. Okay. Divide by 5, good. Go ahead, put that in your calculator and see what you get. I'm sorry? 2.6. 2.6 inches. No, radians, sorry. Okay, little r, radians. So are radians always going to be in terms of pi? No, they're going to be in decimal as well. Okay, so this is 2.6 radians, and that's your angle measure. Yep. Theta? It's in your pi key. In your pi key. Okay. How do you guys feel about that? It's not bad, right? You have to know the formula, and you have to know what each piece means. So let's try another one. If a pendulum swings through an angle of 0.55 radians, what distance does its tip travel if it has a length of 8 feet? You guys know what a pendulum is? Yeah, so like, see how I have my keys on this, what is this called? Lanyard? All right, so this would represent a pendulum, something hanging down with a weight at the bottom, okay? Pendulums swing. So if you think about the path my keys are traveling, that would be my what? My arc length. Good, because it's a curved path, right? What would the length of the lanyard represent? The radius. And the amount that it's moving at the vertex, my finger? Theta. In what? Radians. Very good. Okay, so I want you to draw this picture, and then let's see if you can answer it. And I'm going to pause here, and we'll come back. Okay, so when we think about a pendulum hanging straight down, right? Were we given a length of the pendulum? The pendulum was 8 feet. Okay. We know that it swings and creates a curved path. Were we given the distance at which it swung? No, we weren't, right? So what is that called? What variable are we using for that? S, good. And were we given the amount that it rotated? What was it? 0.55 radians. Very good. Okay. So we've got my picture all labeled. So now all I have to do is plug in. I don't know what S is. My radius was 8, and my angle of rotation was 0.55 radians. So now I'm going to do what? Multiply it. What do I get? 4.4. Careful. What's the unit? What's the unit? What is this that I'm looking for? It's feet, right? The length. Feet. So watch your units. The only time you're going to use radians is if you're finding the angle. Okay? Good. We getting it? Awesome. All right, so we have to know how to convert from degrees to radians and radians to degrees. A lot of times what's going to happen is they'll give you this word problem, but they'll give you the angle of rotation in degrees. Do we want it in degrees? No. So there has to be a way to go back and forth between degrees and radians, radians, degrees. So we have a really nice, easy proportion that we're going to use. Does it have to be memorized? Yes. Okay. Ready? Write it down. We're going to do degrees over radian equals 180 over pi. Okay? And this will work for conversion between degrees and radians to degrees. Either way, it will work. Okay, so degree to radian or radian to degree. Either way. Okay? So, a couple words that you guys need to know. One of the important ones when going from degrees to radians is exact. Okay? If it tells you to leave it in exact form, it means in terms of pi. What does in terms of pi mean? What are you going to have in your answer? A pi. So like pi over 2 would be an exact form. It's in terms of pi. Okay? 0.5 pi, or, well, 0.5 would not be an exact. That'd be decimal. So you have to know the difference there. Okay? All right, so what was the first one? 90. Now 90, you guys should be able to very quickly, not even have to use this, what is 90 in radians? Exact form. Awesome. Pi over 2 radians, right? Excellent. So some of these you're just going to know. Now it gets a little bit more difficult when we get into things like 120 and, what's the next one down? 225? Okay, so 120 and 225. So let's look at those ones. All right, so is that degrees or radians? Degrees. Where's it going to go? Where's it going to go? If it's degrees, where's it going to go? Where it says degrees, right? So we're going to put 120 over, am I going to write out radian? What variable do I like to use for radians? What variable do I like to use for radians? Theta. Okay. Equals 180 over pi. Okay. How do I solve proportions? Good. 120 pi equals 180 theta. How? Good. Divide both sides by 180. Do I like decimals? No, I like fractions, right? So I want to reduce 120 over 180 because I want to keep my pi. We want it in exact terms. So 120 divided by 180 reduces to what? 2/3. So this is 2 pi over 3. All right, so 120 degrees is 2 pi over 3 radians. Okay, so it's just cross multiplication and then simplifying. All right, so why don't you take a second and you guys do 225, and then we'll move on to going in the opposite direction. Okay, who wants to set it up for me? Don't everybody jump at once. What do you got? Great, keep going. Great. Okay, how does it reduce? Great job. 5 pi over 4. Awesome. Okay. How are we doing, guys? Okay? Any problems? Awesome. All right, so we've gone from radians to degrees, or degrees to radians, pretty simple, right? Now remember, we're not always going to leave it in terms of pi. Sometimes we want it as a decimal. It's just going to depend on how they're asking the question, right? We will very often have to go from radians to degrees, okay? Are radians always written in terms of pi? No. So we're going to have to know how to do both methods, but we're going to look at the ones that are in terms of pi for now. Now, when we're going from radians to degrees, when we're talking in terms of pi, this is actually really simple because I know pi is how many degrees? 180. I know pi radians is 180 degrees. So these are actually really easy, okay? Because all I have to do is instead of writing pi, I'm going to write 180, all right? So to convert these, I'm just taking pi and putting in 180 degrees, okay? And I put that in my calculator to see what it equals. So 5 times 180 divided by 6 is 150 degrees. Okay, so all I have to do if I have my angle in radians in terms of pi, I just have to plug in 180 for pi, and it's going to solve that out for me. So why don't you guys go ahead very quickly, do B and C. 3 pi over 2? 270. You guys have to know that one off the top of your head. That's one of those ones right on our unit circle on the 90s. Okay. 3 pi over 4? 135. Very good. How do you guys feel about that? Good? Okay. Okay. So we talked about radians not always being in terms of pi. So if it's in terms, written as a decimal, like 5.8, and I want to change that into degrees, I'm going to have to use what? How do we change degrees into radians? Yeah, we used our degrees over radians equals 180 over pi, right? So how am I going to change radians into degrees? Same way. Okay, so theta is 5.8, so let's go give that a shot. So again, tell me what the proportion is. degree over radian. Good. So is this degree or radian? It's radian. Where's it going to go? Where it says radian, right? So I'm going to write x for degree, 5.8 for radian. Okay? Cross multiply, good. X times pi equals 180 times 5.8. All right. How'd you get it? What do I do? Okay. 180 times 5.8 gives me 1,044. All right, I'm not done. Yeah, and what am I using for pi? Nope. Because remember, I'm going to degrees. So what do I use for pi? Yeah, your pi key. Please use your pi key. No trick question. Just use your pi key. Okay. So we get 332 approximately. Okay. To the nearest degree. 332. So there's going to be a lot of occasions where you want to take radians and turn it into degrees, because when we start drawing things like rotation diagrams to find reference angles, it's going to be much easier to do it from degree and then convert back to radians if you need to. Okay. Okay. We got one more question, I believe. All right, an angle drawn in standard position whose radian measure is 2 radians would terminate in which of the following quadrants? Is this 2 pi radians or 2 radians? 2 radians. There's no pi on there, right? So this isn't 360 degrees. So how can I figure out what this is? I need to go from radians to degrees, yeah. I need to go from radians to degrees to figure out where I am, what quadrant I'm going to terminate. So 2 radians. I want to switch that to degrees. How? X over 2. Great. Now what? Very good. Pi times x equals 360. Great. And I'm going to use what when I divide by pi? The pi key, 3.14159. All right. Just use the pi key, please. And I should get, yeah, 115 approximately. So what quadrant would that angle terminate in? Right. So here's my rotation diagram. Standard position, right? 115, maybe about, that's probably way too much, but second quadrant. Okay, so 115 approximately is 2 radians. Getting the hang of it? It's not bad, right? Okay, so your homework is pages 6 and 7 tonight. You should be able to finish that all up. You will have to, for a few of them, you're going to be given radians. You're going to be asked to draw the rotation diagram. So if you need to change it to degrees, cool, change it to degrees. And then you'll have to find the reference angle. So does everybody remember your rules for reference angles by quadrant? What's this quadrant? Yeah, it's itself, right? Reference angle over here. Good, here. Good, and here. Good, so those are your quick rules for reference angles, guys. So if you're finding reference angles, you can use those if they're positive, less than 360. Okay?